we've got the depth of the excavation here, H equals 15 feet, your active and passive pressures, your unit weight of soil above the water table, and your unit weight of soil below. And also added in here is a surcharge. So the problem is going to be to find PA1, PA2, PE, and PJ. Then second part is going to be solve for Z in terms of D. And then the third part is skipping ahead and giving you a moment. We're going to try to choose a sheet pile. All right, so basically we're going to start this by going here. And I'm just going to redraw this little diagram real quick. So as straight as I can. Just so we have it here to reference. Let's go a little thinner here. Okay, so here's our setup, and then I'm just going to draw these in right here. Do a little, ooh, that's a bad line. Oops. Let's just keep it solid over here. So here's our PA1, just so we label everything. PA1, here's PA2, and let's also just draw out, I'll choose a separate color. I'll just go red for this. So I'm going to stay right along here. We're just going to draw out the typical guy that you're used to seeing. On here. Okay, so I'll even put in a couple other things here. This here being PE. PJ, and these just happen to line up. They don't necessarily always, just the way I drew it, they do. So here's the variables that we're looking for: PA1, PA2, PE, and PJ in terms of D. So first things first, if you notice back in the problem here, there's a surcharge. So how do we deal with that? Well, one way is in your calculations you can kind of add the 325 PSF on top of whatever pressure you calculate otherwise, but a pretty easy way to do it that I'm going to show here is to make it into an effective depth. So we're basically going to take that surcharge, say, you know what, if it was just more soil, how much would that add? So we're going to deal with the surcharge using an effective depth. And I'm going to label that DE. Okay, so how do we find that effective depth? Well, the effective depth is just going to be H, the regular depth, so DE equals H, plus what if this 325 PCF were just put in terms of soil, in terms of the unit weight? How would we do that? Well, we're just basically going to take the ratio of the two. So we're going to take this Q and divide it by the gamma up there. And that'll give us basically what depth this would equate to if we were to just have this gamma unit weight of soil. So that equals 15 plus 325 divided by the unit weight, which was 108. That gives us 18 feet. Okay, so instead of D, we're just going to be using DE for all our other equations here. So starting with PA1 equals this value here, which since we've just brought it to a depth is just going to be the vertical pressure, which is gamma, times dE. That's the vertical, right? And then we just need to change it so that it's actually acting horizontally, which we're talking active. We use this Ka value. Okay, so that one, 108 times 18 times Ka, which in this case is 0.45, gives us a PA1 of 875. Oops. 875. All right, and that's our PA1. So we already got one answer. Okay, so 3. Let's find PA2, because it asked for it specifically. And PA2 is just down here, and you'll notice that I didn't draw a straight line because our gamma down here is different. So the vertical pressure is going to change slope here. And also, we're just going to be using D. We're going to have to put this one in terms of D because we actually don't know what D is yet. So that one is just going to be PA1, so it's the pressure where we started here, PA1, which we already know, plus the vertical component here, gamma, and this time it's gamma submerged, make sure we use the right one, times the depth, the D, which is just D, times, again we're talking there. So we had the vertical component, switch it to a horizontal. So that's just 875 plus gamma submerged was actually 95 times the Ka, we'll put in there 0.45 times D. So we get PA2 equals 875 plus 43D. And there's another answer. Okay, so those two are pretty easy. Easy to think about those going right there. Now we get a little more complicated because we're going to be talking about PE and PJ. We'll start with PE, with PE being this value here. And like the professor described, it's not really an actual value that comes out. It's the difference here between a couple values. So remembering that PE is equal to the passive pressure, I'll call it, so just write it out, passive on the excavated side minus the active on the retained side. Okay, so you're talking about a region up here, active acting on the retained side, passive on the excavated side. So that value then is going to be something that we're going to have to find. So I'm going to call this one PE, actually let's call it P passive excavated, PPE. Okay, so that's going to be that minus this active on the retained side, which is actually your PA2 value, which we've already calculated. So this is PA2. Okay, this is PE. All right, so that equals what? What is the passive pressure on the excavated side? So that's here. So it's going to be, if we were to draw a line, let's do it green, it would look like this. Okay, this would be our PPE over here. So what is that value? Oops. What is that value? Well, it's pretty simple. It's just gamma submerged, because we're below the water table, times the depth D, right? Because that's what we're talking in terms of, and it's passive, so Kp. Okay, and so that guy, I'll just write it down here, is going to be 95, Kp being 3.89 times d. Okay, and then we're going to subtract Pa2, which is right here, 875 plus 43d, so minus 875 plus 43d. Combine the d terms and all of that, we get a negative 875 plus 327d. Okay, so that's our PE. Okay, PJ, go back to the definition of what PJ is, which comes over here. We're talking about that being the difference between the passive pressure on the retained side minus the active pressure on the excavated side. Okay, so that's PJ. We're going to call this value PPR for passive pressure on retained side, and we're going to call this AE, active pressure, excavated side. Okay, so what are these values, PPR and PAE? Well, the passive pressure on the retained side is equal to basically the over here is the passive pressure on the retained side. So it's basically the same calculation that we use to find active, but we're going to be using Kp. So if I were to draw that, let's say in whatever the color this is, it's going to be a little steeper because passive pressure is a little stronger. It's going to change a little bit. It's going to be over here. So this is our PPR over there. Okay, so anyway, back to calculating it then, you're going to go and take basically what it is above the water table, so it's gamma. We're going to use that effective depth, Kp. We're going to add to it, now we're below the water table, gamma submerged times d times Kp. Okay, so that one equals, plug in all the numbers, we get 756, 75, 62 plus 369.5d. Alright, so that's just this PPR. And then PAE is basically, if we go up here, we use orange, it's this starting here, it's going to be less than that passive, and we'll call this PAE. Okay, so going back to this color, how do we calculate that? That one's a little easier. It's below the water table, gamma sub. We're going to put D, and then it's active. So it's just that easy. So that one comes out to 43D. Alright, so what is PJ? PJ equals PPR minus PAE. So it's 7562 plus 369.5D minus 43D. So we end up with PJ equals 7562 plus 326.5 Alright, so there's our answers for part A, PA1, PA2, PE, PJ. Alright, so part B then is going to be a little tricky. Solving for Z in terms of D is what the question asks you to do. So how do we do that? Well, what we end up doing, here's our Z, is this height here, Z, right? So this is where those triangles, and go back to the tutorial for a really good example on how these triangles work. But if you remember, we're going to be taking triangle here, we're going to be taking this, adding trapezoid here, we're going to be adding this triangle here, and then subtracting off all of this, right? So that, subtracts the double, subtracts this that doesn't count, and it's going to give us that so that we get our sum of the forces. So summing the forces in the horizontal gets us, and I'll run through this quick, but upper triangle, PA1 H over 2. The trapezoid down there is just PA1 plus PA2 over 2 times D. That's this trapezoid right here. Starting there, going up there. We're going to add to that this small triangle down here that goes right there, which is PE plus PJ times Z over 2, so there's our Z term, minus, now we're going to subtract off this triangle all the way up to here, down to there, so that it evens out, and we get PE plus PA2 times D over 2. So it's triangle, that's why there's all these over 2's. So that's PE, PA2, D over 2. And of course, this is a little confusing because they're right next to each other, but they're not really, just the way I drew it. And so where the sum of the forces here, if we're in equilibrium, equals 0. So basically, I'm not going to show it here, but here's your Z term. You've got all of these values, PA1, PA2, PE, PJ, PE, PA2. You're just going to plug them all in from here and get your Z in terms of D. Yeah, so actually if you continue out the problem, take moments and all that, I'll just write out what the answers are. Z being 5.7, D equals 19.9. Z. Okay, so you get all that. Once you have Z and D, you can come back, find X and Y, which we're not going to show here. Go back to the tutorial for one of those. And then you can find what the max moment is. So in max, in this case, we gave you the answer in the solution, or in the problem, it was 115,439 foot-pounds. And so there's where part C comes into play. And part C, we're trying to find what's going to work. So we need to find the section modulus required, and that's going to equal the moment over the allowable bending strength. So what are these? 115, 439. Let's keep our units foot-pounds. And the bending strength, if you go back to the problem, it said it was grade 55 steel. And grade 55 steel, if we look here, the bottom, right here, grade 55 steel, the allowable design stress is right there, 35,000. and that's in PSI. So divided by 35,000 will be per inch squared. So here, just be careful. We're going to convert these feet into inches so that we get all this correct. So doing all the multiplication there, we end up with 39.5. And that 39.5 is our S in inches cubed per foot of wall. So we're going to go back to this chart and look here. This is section modulus per foot of wall, so we're going to look down this column for something that'll work. So this guy will definitely work. This one almost works, but not quite, but we'll just say PZ38. Let's use that one. Here's your solution. So here's just a small little addition. Dealing with surcharge, dealing with sizing of the sheet piles to add to your repertoire. All right, that's it. Thanks.